Okay, so we're back here with example 6. And so it says to find the measure of the arc using the pie graph below. So here we're going to do a little algebra, all right, with a little geometry. So what we have here is we have this circle, all right, and S is the center of the circle, all right. So what we have here is a bunch of central angles, okay. So each of these little sections, all right, is going to represent a central angle. And what we need to do here is we need to find the measure of, I think the first one says of arc CD. Okay, so I need to find the measure of this arc. So if I go ahead and just highlight the central angle that I'm looking at, all right, remember that if we can find the measure of this central angle, that's going to match the measure of the arc. Okay. The issue though in this question is that I have the percentages that they represent, but I don't actually have the degrees. Like the 14, the 14, the 16, the 18, the 18, and the 20 don't represent the degrees. They represent the portion of the circle that we're talking about, okay? But we can find the degrees. So what we're going to do is we're going to take the fact that the degrees of the circle is 360, and we're going to multiply by that percentage of 18, and that's going to give us the measure of the central angle, all right? So if I'm multiplying by the percentage, I'm going to turn it into a decimal, which means that I'm going to turn the 18% into 0.18. So I'm going to multiply the 360 by 0.18. So 360 times 0.18, and that gives me 64.8. Let me try that again, times 0.18. Yep, 64.8. So what I just found was that the degree of that central angle is 64.8. And I'm trying to find the arc, and remember that the central angle matches the measure of the arc, which means that that arc is also 64.8 degrees. So that arc is 64.8, and because it's less than 180, we know that that arc is going to be a minor arc. So let's try the next one. All right, so again, it's the same exact thing, only this time I'm trying to find the measure of FE. All right, so soccer. And we need to find this central angle right here, okay? So what I'm going to do is I'm going to do 360 times that percentage of 0.14, and I got 50.4. So that 50.4 represents that central angle, which means that that arc also has to be 50.4 degrees. Okay, so example 7 now is saying find the measure of the missing central angles. All right, so what we know using the sum of the central angles theorem is that if you add up all those central angles, they have to equal 360 degrees, right? So if you look at this first example, nice and easy, all right? I'm going to just add up the 145 and the 165. So I'm going to do 145 plus 165, and I'm going to get 310. And then I'm going to take that 310 and subtract it from 360. So 360 minus 310 gives me 50 degrees. So that means that that x right there is equal to 50 degrees. Same concept for this one, all right. This one I have this 90 degrees right here. So now I'm going to add up 85 plus 40 plus 90. And I'm going to get 215. But I have to take that 215 and subtract it from 360. And I got 145. So that x here is equal to 145 degrees. Okay, so again, I know that this is a ton of information in these first two sections, all right, but we now have this idea of adjacent arcs. The thing though is that it connects to ideas that we've had in the past. So adjacent arcs are arcs that share exactly one endpoint. So if I would draw a picture of this, all right, so I'm going to draw my circle. I'm going to put in my center, but I'm not really concerned about the center on this example because I'm looking at adjacent arcs. So what I want you to do is actually put 3 points along that arc. And I want to highlight the arcs that I'm looking at. All right, so if I go ahead and highlight this arc right here, and then if I highlight this arc right here, these two arcs are adjacent arcs because they are only sharing that one endpoint, okay? And the way that this connects is what I'm going to do now is I'm actually going to take this picture and I'm going to copy and paste this. And this time, I'm going to go ahead and add some letters to this. All right, so I'm going to go ahead and just name this one M, this one N, and this one P. And so this is the arc addition postulate, all right? And again, this connects to segment addition postulate. This connects to angle addition postulate. But what it's saying is if you take the measure of arc MN, so if I take the measure of arc MN, and I add that to the measure of arc NP, then that is going to equal the measure of all of arc MP, right? So again, if MN was 50 degrees and NP was 40 degrees, right, then that full arc is going to be 90 degrees. So if we look at example 4 now, it says find each measure in circle F, all right? So for the first one, it says to find the measure of arc AD. So the first thing we have to look at is the fact that these are all central angles. And because they're central angles, we know that the degrees of the central angle corresponds with the degree of its arc. So if you look at AE, that's going to correspond with the central angle of 63 degrees, which means that this arc is 63 degrees. And then if we look at arc DE, sorry, this arc right here, all right, that's going to correspond with the 90 degree central angles, which mean that this is also 90 degrees. So if I add the 90 degrees and the 63 degrees, I get 153, which means that the measure of that arc of AD is 153 degrees. So now let's do the measure of arc ADB. So if I look at this one, all right, so ADB is going to be, let's go ahead and zoom in. So A to D to B. Okay, so it's going to be this full arc. And we know already, because it's a major arc, it's going to be more than 180 degrees. So what I want you to look at, though, is this. All right, I'm going to go ahead and highlight this. Because if you look at arc AEC, that's a semicircle. So we know that this arc right here is 180 degrees. Okay, so, and then from there, if this angle right here is 63 degrees, this angle right here is a central angle, I'm sorry, is a vertical angle. So I know that this is also 63 degrees. And so if you look at BC, then this arc right here is 63 degrees. So I'm going to add 180 plus 63, and that's going to give me 243 degrees, which is going to be the measure of arc ADB. So 243 degrees. Phew. Okay, so we are now at the next set of vocab, okay? And I'm actually going to pause here, and then we are almost done.